So thanks for coming along tonight. This is the 12-factor key to scaling, the cloud talk. So first off, who am I? My name's Mikel Lindsaar. That's Michael as in Michael, not Mikel, or any other strange pronunciation. You're going to have to forgive me. I am from Sydney, Australia, so we spell stuff differently. Organisation has an S in it. Centre is spelled R-E, not E-R. And you'll notice that on the slides. They're not typos. It's just English. So my Twitter handle is @Lindsaar. Feel free to tweet me if you have any questions afterwards. I've done some open source stuff. I did the Ruby Mail gem. Mail's been downloaded a lot of times and it's used in a lot of places. And it actually helped me start my whole business. So if you're ever interested in starting your own consultancy or something, I can't recommend open source work highly enough. It gets you in a lot of doors. It's really simple when a client calls you and says, oh, we'd like to use you, but we're not sure if we'd like to use you. And you say, well, you already use me. We send all your emails for you. And they go, oh, okay, cool. So then we can hire you. Yeah, so that's handy. I founded a few companies, Reinteractive, and that's the reason I'm here. We make confident software. We have two other products, OpsCare and CodeCare. So we focus on Ruby on Rails. This talk is not focused on Ruby on Rails. It'll apply to anything. But OpsCare is a service that we provide that maintains and manages Rails production environments. So you can get back onto coding stuff that earns you money. CodeCare maintains the software itself over time so that you can get back to coding stuff that makes you money. So that's what we do. We also make our own software. Founded Exec.io, that's sort of a business analytics type company. And also Flood.io, we do performance testing and load testing in the cloud. JMeter and Gatling and all that sort of stuff. So if you ever need to do any performance testing, someone said about Flood.io, which I really liked, stupid simple and stupid cheap. So that's two good things. So we're not here to talk about my companies, we're here to talk about 12-factor. So what is 12-factor? Who here has heard about 12-factor before today's talk? Okay, good. Who uses 12-factor in production? Okay, good. It's an interesting thing because there's like a degree of 12-factor, right? There's sort of like not using 12-factor at all and using 12-factor to the letter, and pretty much every implementation is somewhere in between that range. So, yeah. So I'm going to talk about 12-factor and how it applies to the cloud and how it applies to scaling cloud apps. You are all probably here because you have some sort of interest in scaling, or you hope that you'll have some interest in scaling at some point. The nice thing about 12-factor is if you do it right to begin with, scaling becomes not a problem. It really becomes an implementation detail that you deal with when you get to it. And I'm going to show you some ways to do that. So what is 12-factor and, how did it come about? Well, Heroku, who are a bunch of cool people down that way, and basically they learnt through deploying indirectly hundreds of thousands of apps the key things you need to actually make an app deployable and scalable. And they codified that into a philosophy, if you like, called 12-factor. So why should you care? What's this got to do with you? Well, actually quite a lot. And as I go through this talk, you'll see that there are some ideas there that will help you scale your apps and run maintainable and usable code. But from a reinteractive point of view, we've dealt with more than 100 Rails apps, from the hobby site that someone's just built together and are hoping it's going to turn into a startup, all the way up to a client of ours that does 50,000 signups a day. And we use the same infrastructure across all of that. So it's the same tool chain to deploy it, it's the same tool chain to set it up, it's the same tool chain to get it running. And the reason we can do that is 12-factor. So that gives you an idea of how powerful it is. If you can scale from no signups per month to 50,000 signups per day, and you're not changing the way your app's deployed, that's pretty cool. So this is why we're going to talk about it. But before we talk about what 12-factor is and why you should care about it, we sort of have to define something first. And really that is what is cloud or cloud servers. Now there's a common misconception, and I don't know about you folks if you have this misconception, but a lot of the business people that you might deal with will definitely have this misconception. And that is that most of them think the cloud is just a virtual data center, and this in Ruby means not. So the cloud is not a virtual data center. If you're using it as a virtual data center, you're sort of using it, well, not wrong, because it is one way to use the cloud, but you're not really taking advantage of what the cloud can offer. So what's a data center? So a data center has long-running instances. So if you're building a data center, you want to buy the biggest hardware you can at the lowest price you can and have it sitting there and it never breaks down and it's always running, right? Because you're optimizing for installation cost and running cost. So you want to have long-running instances. You obviously don't want the server breaking every day. I mean, that's sort of given. Then you've got critical instances. So every instance you have in that data center is pretty much critical. You're not going to install lots of stuff that can just break, right? We're talking about physical data centers, right? It's probably going to be pretty expensive hardware, maximum performance per instance. So you're going to be optimizing for how much RAM and CPU you can do for every virtual server or whatever you're running. And you want just-in-case capacity, right? So when you're installing a physical data center, you're going along the lines of how much traffic at my maximum point are we going to have over X period of time, and I need to build my data center to handle that traffic, right? Does that make sense? Yep. So a virtual data center, if you then just took that data center and you put it in the cloud, it would look like this. Exactly the same, except you're not buying the hardware, right? I have no metrics about this, but I'm going to give you a really, accurate statistic. 95% of all Amazon accounts are like this, right? I've just pulled that number out. That's probably correct. But, they're instances that are booted. They go, well, I've got my LAMP stack, Linux, Apache, MySQL, and PHP. It's all on one box, so I'm going to get an, EC2, X3, super large, massive instance, have it running. It's going to cost me $500 a month, and that's my server, right? And then they go, well, I'm actually going to go cloud, and then they pull out the MySQL database and boot that up on a massive RDS instance, and that's my server, right? And then they go, actually, we've now got too much background workers happening, so I'll boot up another really big server and run the background worker on that, my app server on this, and MySQL, and that's my network. But they're all still just-in-case hardware, right, or servers. You're hoping that at no point will your traffic exceed that system's ability to handle the traffic. And if it does, your pager goes off and then you're figuring out how the hell am I going to scale this, because all of it's been built up over time by SSHing into the box and manually installing stuff and all that sort of stuff, right? Sound familiar? So this is not an incorrect way to do it by any means, but it's not a very efficient way to do it. And the promise of AWS is just-in-time delivery. And if you talk to any cloud provider anywhere, their sales reps will say this: run what you need when you need it. And that's the promise of the cloud, but no one sort of takes advantage of it, which is sort of funny, right? So I guess it was funny. I gave this talk, or a version of it, to about 16 AWS pre-sales engineers in Australia. And at the end of it, they went, oh, finally, someone who knows how to use AWS. It was actually quite funny, because most of their clients buy these large instances that then are basically 99.99999% idle, right? And then at lunchtime on Tuesday, they spike and they handle that traffic, and then for the rest of the day, they do nothing, right? Because that's when their marketing campaign went out. And we had quite a few clients at Reinteractive who would come to us with their Rails apps, and they'd go, well, look, we've got these Rails apps running, and we want to be able to scale them. And we go, okay, good. How do you scale? And they went, well, we don't know, The way we do it is we sort of boot up another instance that's been shut down for 4 months, and then let that boot up, and then we log into it, and we try and replay all the manual commands, and we do it from the bash history on the main box. And we go through the history of the command line, find everything we've installed, and then type that out. It takes about 5 hours, and then we get it up and running, and then we have to adjust it to make it work, because we forgot that this thing's now got a config file that the other one doesn't have, so we have to SSH that across, but we can't do that because there's no key on the other box because the other one can't connect to it. So then we cut and paste it out of one console into the other, and I mean, my God, right? So they come to us and we help them build it into a scalable architecture. And the number one thing we have to do before we can put it onto our stack, or any stack that's scalable, is make it a 12-factor app. And that can take us a day, a week, a month, depends how bad the app is. So if that's what you want to achieve with a AWS account or any sort of cloud account, what is the cloud then? Well, a perfect cloud environment would be that. None of the above. You would have short-running instances. You would have disposable instances. And when I mean short-running, I mean they only boot up when you need them, right? So you might have 2 instances running all day, and then at lunchtime, that's when everyone logs on to your Facebook for Dogs, Wolfbook account, and they all want to marry up their dog with your dog, and so at lunchtime it spikes massively. Well, at 11:55, you should be able to boot up 20 instances and turn them off at 11:05. So if your cloud environment is not doing that, then you're not 12-factor and you're not really taking advantage of the cloud. We actually have some clients that come onto our ops care service that are spending, say, $5,000 a month on their hosting, and they don't even have a staging environment, right? And we'll move them onto our service. They'll get a staging environment, and it will end up costing them about $3,000 a month. And the reason for that is that even though we're sometimes tripling the number of instances, we turn them off when they're not needed, right? And we can scale it predictably. We had one client who always had these press releases that go out, and whenever the press release would go out, they'd get a massive spike in traffic just from the nature of who they were. So we actually we have a tool, which actually you'll see a bit later, that allows them from the command line just to scale all their servers. So just before they hit send on the marketing campaign, they just scale up to double their instances, and then it scales down after about 5 hours. And that makes it really simple for them to do those press releases. Previously, they'd have to start scaling the day before. And you can imagine what that was like to their morale. It sucked. So if you want to do the correct cloud use, really what you want is just in time, not just in case. And really this is sort of the overriding litmus test about whether or not you're using the cloud efficiently, right? If you're using infrastructure just in case and you've got excess capacity there that's doing nothing, then there are savings that you can have and make, and hopefully this will help you show how to do that. Good, so 12-factor helps you achieve this. How? Well, I'm glad you asked. That was amazing how many people asked just then. That was really good. So the first thing is 12-factor has 12 factors. I know that's a really complex, mind-blowing idea, right? There's 12 individual factors, and the first one is code base. So that's actually a Roman numeral number 1. But funnily enough, one code base is actually what 12-factor is also about. This first principle is having one code base. So sometimes you'll have apps, and we've had a couple of clients like this, where they've got one GitHub repository, and it's running 4 versions of their apps. And each app has got a different code execution path. Like there's some code that isn't actually even run in the other app, but they've got the same repository running multiple apps. That's a violation of 12-factor. The reason for this is that you don't want to have situations where your developers develop something that breaks your app in production through an unintended consequence that can't be easily tested from the command line, right? So you want one code base for your app. You might have, like in this model here, you might have all these images, by the way, are taken from the 12-factor website, and they're Heroku's, and good work, Heroku. You might have one code base which has multiple environments. That's totally fine. As long as those environments are not defined by the code base and are instead defined by environment variables, which we'll go over in a minute. So you might have one code base, you might have develop branch going to your staging environment, you might have a UAT branch going to staging or whatever, master might go to production or blue-green or whatever you want to do on that, that's fine, but it needs to be one single point of truth. This is a really important first step of 12-factor, and sometimes it's the hardest to get in. One of our clients that we were working with, they had 2 apps, well 3, well 4, depends on how you look at it. We had to rewrite the entire apps just to get this step in, basically from scratch, right? And it was, anyway, a lot of money. But the result is that now they can just scale really fast, and that saved them huge amounts of money. So this first one's very important, one code base. And if you can get your app to one code base, that's a very good start. Second part about 12-factor is dependencies. So Dependencies are actually the thing that blows up apps the most. And if you want an example of this, who here's built a hobby app a couple of years ago and then gone back to it, like a hobby app, like just a side project, gone back to it later and it just doesn't work? You just can't get it booting or whatever? Right. So there's this idea of what's called software entropy, right? Entropy is the concept of things getting all mixed up and over time, right? And software doesn't actually entropy, right? It's still a 1 and a 0. The software that you write today, if you leave it in the GitHub repository, if you come back to it in 40 years, it will be exactly like you wrote it today, right? It won't change, but you will not be able to get it running. Even though nothing changed about the app, it just won't start unless you 12-factor it, but it won't start. And the reason for that is the software doesn't change, but everything else around it moves on, right? So you might be depending on ImageMagick version 2, and 5 years later, it's now ImageMagick version 11, and for your, to crop your wolfbook photos of your cute puppy so that it fits into the little profile picture on your Facebook for Dogs hobby site. And that gem or that software library just won't work anymore. You can't install it. Even though you can still download the gem, it depends on some system binary which doesn't exist anymore or has moved on. This happens all the time. We have a client right now who just contacted us. They have a Rails 2.1 app, I think it is. And they said, we need to upgrade it. And it's like, okay, let's start. And in a couple of months, we might be done, because the software libraries that they relate to and all of the system infrastructure that relates to it, you can't install it. You just can't get it running. So you sort of have to upgrade the system and spend all this time catching up than not. So where 12-factor really helps with this is that the application itself is declarative on all of its dependencies and doesn't depend on the underlying infrastructure to start, right? If your app needs ImageMagick version 2, well, that's bundled into the app or the build tools or however you build it, and it knows how to install it, right? If it depends on a certain version of blah, well, that's bundled in. And then what that means is that in 3 years' time, when you go to install it, the 12-factor app knows to download Ubuntu version 9, not Ubuntu version 14, to get your app started. Now, it might still be full of security holes, that's another problem, but you'll be able to get it running, right? And this is a really important thing. If your code base, anywhere in the code, shells out to the command line or something to run some process, like image manipulation or doing an external fetch on using curl to fetch some document, and your build tools don't install that thing for you, then you're violating 12-factor. So make sure you have all of your dependencies in it. Yeah?
So microservices become more popular because it minimizes dependencies. Could you explain that a little bit more?
So the question was that microservices are becoming more popular because it minimizes dependencies. Yeah, so that's only true if each microservice follows 12-factor, because it's really funny. There was this flowchart that I saw that says, do you need microservices, right? And the first line was, are you really, 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 really sure that microservices are going to improve your code? Yes, no, you never need microservices, go away. Yes, are you really sure? Yes, are you really sure? Yes. So microservices have a promise of decoupling infrastructure, and that's really cool. And that will fit in with 12-factor, and you'll actually see it. I think it's about number 8.8, talks about depending on resources as a binding on a URL, and microservices fit into that really neatly. So if you do have microservices, this will help that, and the 12-factor will still work. So then you would apply 12-factor to each microservice, and if you do that, you'll have a much happier life. What you don't want to get into, and I've seen this with some clients, they'll have one box that's running 4 or 5 microservices, right? That's dangerous, because if you need to upgrade microservice 1 and it updates something in the command line, then microservice 2 blows up. What are you going to do, right? So, yeah, microservices fits really well with 12-factor, as long as you follow 12-factor. The third point is configuration. So, configuration should be environment variables, not anywhere else, really. You can do it with config files, but the problem with config files is that during your deploy, config files are really easy to overwrite by accident, and bam, there go your config files. And worse, you sort of need to copy them to every server before you deploy it, and then you can't change it easily. Or more to the point, you have to then change it on every server. So with things like CloudFormation and stuff like this, on Amazon, you can actually specify your config files, environment variables, as part of the role. So when it boots up, it gets the environment variable. And no matter how many of these instances you boot up, they get all the environment variables. So that's a much more portable way of doing it. It's how we do it with our ops care stack. Yep.
Where do you keep the original?
Where do you keep the original environment variables? In a vault somewhere. I mean, like for us, the environment variables live within the CloudFormation thing, and then we would store them in a secure, like, password vault or whatever's needed for that client. Yeah.
So, how do you do this for Lambda functions, especially Java 8?
Yeah.
I mean, do you use DynamoDB?
You can. Another place to store them could be in the database if you trust that database. But, you know, Lambda, yeah, good question.
We've got a whole day of that tomorrow, so I guess.
Yeah, ask them. See if it's on their roadmap. Yeah, that's one of those things where, anyway, I mean, last year Amazon released 375 features, which is more than one a day. So Lambda was one of those features. I mean, so they're probably playing catch up. But yeah, really good question. But still, you see, Amazon Lambda, though, is actually quite 12-factor just by itself, because processes are a first-class citizen. The instance will appear and die. You know, it's not like they're long-running processes or anything, so it's pretty cool. There's a question over here? Yeah. So the question was about environment variables and integrating with Docker. There was a lot of problems with Docker early in the game about being able to pass down environment variables into the sub-images, but it still does apply. Like, you would put the environment variables within the Docker image that you're going to boot, and actually have that exist, and then as it boots up, it reads it, and there you go. The reason you have it in environment variables, and how you get those environment variables into the system is going to vary on every device, right? The way we do it with our ops care stack is we take the environment variables and we put that into a gzipped file that's got a password on it. That sits inside the Amazon environment store. As the instance boots, it reads that gzipped file. The instance has a stored string to unencrypt that gzip file. That gzip file gets unencrypted at the right point of the boot service, and then that gets inserted into the environment, right? That works really well for us. And the reason we do it that way is that we can then change the environment variables, bounce the instance, and the new config's running, right? What you don't want to get into is situations where you have to do a new release to get your environment variables changed. So if you can do it more in a way where at boot, the system goes and fetches the environment variables, that's the best way. You can even do this with things like Chef. You can have data bags in Chef. Lots of different ways to solve it. But the important thing and what you're really trying to achieve is you don't want to have to do a release to change your environment variables. And how you achieve that is it's going to vary. A really good litmus test on this, if you've done it right, is if you open sourced your entire repo tomorrow, would you have a security breach? And if the answer was, gee, I don't know, then you haven't achieved step one, right? So there shouldn't be any environment variables in config. There shouldn't be constants in config. URLs to resources, for example. Say you've got a Redis server that you want to contact. That should be in an environment variable, not hard-coded in the code base. The domain name of the app, if you worry about the domain name when you're running it. All of these configuration things can be in environment variables. One of the reasons you might want to put, say, for the domain name in the environment variable, which might sound like, really, why not just hard-code it? Well, remember, you're using one code repository for multiple environments. So you might have your staging environment on a different domain name. I mean, you will, right? You're not going to have it on your production. So your app might need to know that, and that's one way to handle it. Or your local box, when you're doing local development, you can then set your environment variable to be lvh.me, whatever it is, and it will refer to localhost. So useful thing. Next point in 12-factor is backing services. So this is all about how, when I said to someone before about number 8, it's actually number 4, so there you go. This is about when you're connecting to other things. So backing services, should be able to swap in and out at any point, right? And the way you do this is you treat them like this, just with a URL. So again, these URLs would be in an environment variable, and this app connects to the MySQL via that auth string, connects to the SMTP and has that sort of stuff. It doesn't have to be environment variable. It doesn't have to be a URL that it's connecting with, but it could be a username and password or what have you. This is another really critical part about the 12-factor, and the reason for that is that if this database blows up, you don't want to have to do a new release to get it to point to a new database, right? You should be able to just change the environment variable to point to a backup database after you've restored it, bounce the box, and it's now connected to the new database, right? Having this, the other point about this is that this is separate to this, right? So you don't have one instance that's got your app servers and database servers and everything else on it, because then, well, if it breaks, you're screwed. Like, what are you going to do? Log in and fix it at 2 a.m. Yay. So the other solution is, oh, it's broken, good. It's 2 a.m., that's not good. So what I'm going to do is I'll go in, I'll restore the database from 3 hours ago. Good, we've got a new MySQL server, swap it over, good, it's running, go to bed, deal with it tomorrow, right? You want to optimize for getting the thing running again on a new whatever and not having to think about how am I going to restore this database or fix this other problem at some early sparrow's fart time. So that's backing services. The next part about it in 12-factor is the fifth one, build, release, run. This is something that a lot of apps get wrong. A lot of Rails apps and all sorts of people, they'll have the large instance and they'll have some SSH script that logs in and downloads the GitHub repo and bundles and does all the installs and then reboots the Unicorn server and it's up and running again. The problem with that is that you don't know if that goes wrong, you can't necessarily roll back because you don't know the state that that box is in. You don't really know what's been done. And this format of building, releasing, and running gets you a much more reliable process in getting a deploy done. So what happens here is, first off, the build step boots up a copy of your environment or boots it up as a fresh build and installs everything on it. So in Rails, that includes doing things like asset migrations and database migration, asset compiling and database migrations and stuff like that. In other languages, it's other things. Like in Java, it might be compiling it or whatever else, right? So it does all of that in the build stage, and this is outside the production environment, right? So that you're not actually touching production at this point. You're building a new image. Then you release it. What that does is that takes that build image, makes it immutable, so it can't be changed. And then you run it. You boot an instance off that image, right? This is how we do our OpsCare deploys. This is how Heroku do their deploys. If you've ever done a deploy on Heroku, it does the same thing. And it makes a very safe application. So I'll show you how that works, for example, in OpsCare, right? So when we start the deploy service, this is more for demonstration, because not a lot of you use Rails, so whatever, but this will give you an idea. The first thing we do is we're going to create a new AMI, right? So Amazon Machine Image. So what we're doing here is we're saying to it, boot up a new workbench off the existing image. So we already have an image running in production off, that would be, the old image would be AMI 68, because we're booting 69 here. So we already have that image running, and that's in our production. So that's booted off a machine image. We boot a new instance off that that's outside of the production environment, and then we do our whole deploy on that new instance that's outside of the production environment. Once that instance deploy is done, and you can see it's doing all of this, migrations and assets and all this sort of stuff. Once it's done that, and we know it works, and we tested it, we shut down that instance, and we make a new image off that, which is the release step. Now that we've got a new image, we deploy it into production. And the way that we do that is we just scale up and scale down the app servers. And by scaling up and scaling down, what happens is it boots a new image, a new instance off the new image, and then when it scales down, it just kills the oldest image first. And we end up in a state where we've got the new environment running, and then we clean up some old releases here that are more than X days old. But we end up with a new image running in the production environment, And at no point have we had less capacity in production or anything like that. It just works. This has a really nice side effect. When so I use OpsCare for one of my apps, and I'm a founder. I write founder code, and it's ugly. And I did a deploy on a Friday evening, because, clients do that. And it was a very innocent deploy, and there was no chance it could break anything. I just knew that, so I hit deploy and let it run. And I knew I was changing something like the copyright on the front page, right? The date. So I let it deploy, and I was running late. The deploy hadn't finished, so I left, and I forgot my phone. So I'm out the door, driving away, totally forgot that I had my phone, didn't have my phone. The deploy accidentally included another commit that I forgot about, which crashed the entire server, right? And I'm away from my desk, away from my email, no phone, nothing. Because we use this sort of deploy process, our engineers who use my app, I told them obviously this was a test to make sure that they knew how to do this, but they noticed that it was down. They noticed that I'd done a deploy. They tried to contact me, couldn't get me. But because we use this build, release, run, all they did was they told it to roll back to the previous AMI. And within 45 seconds, it was back up and running as it was. And that's a really powerful thing. Again, we're optimizing for not having to fix stuff when it's broken. Fix stuff when you've got time to do it. Yeah.
Are you similarly running this sort of work frame when you're in the QA?
Yeah. Yeah. So the question was, do we use the same workflow in QA? Yeah, we use this for all of our environments. So staging, production, whatever. Yep.
You mentioned you're rolling out as an AMI. Do you have an opinion on that? That best practice versus just having a stock AMI and putting your application on top of it?
Yeah. So the question was, we roll our own AMI. Is that better practice than having a stock AMI? We start with a stock AMI, and then every deploy incrementally makes that AMI more close to our app. So every release builds on the previous release, right? Now, the reason we do that is that our boot process takes seconds. Because what you want in this stage, in the release stage, is you want your app to be complete. You want it to be able to boot within seconds. And the reason you want that is you don't want to have to think about, should I scale right now or not, because it's going to take 10 minutes to deploy or whatever, right? So because every release we do on every AMI is a complete app, we can scale from 2 servers to 50 in 45 seconds. Because that's how long it takes just to provision and boot the app, the instance. So that's why we constantly do that. So is it best practice? I don't know. It works for us.
The application's actually is an AMI.
Yeah.
Oh, wow.
So the AMI is totally built, and the AMI is immutable. So every release we build a new AMI, and we recycle all of our instances, which also has a really cool effect in that we are always running on the most recent versions of software that Amazon have to offer, right? So if you've used Amazon for any length of time and you've got long-running instances, occasionally you'll get an email that says, we're very sorry, we have to reboot your box. What they're doing there is you're on box A that's on an old version of the VM software, virtual machine software, and they need to move you to a new box so they can upgrade that old box. In this case, every single deploy gets you the latest machine image. So you're always running on the most reliable, most patched hardware, which is a nice side effect.
So you have some kind of change config build system to build that AMI.
So the question was, do we have a change config build system? Yes. So that's the other part of the deploy script. So we use Ansible for that. Sometimes Chef, whatever. Yeah.
How are you staging in multiple geolocations?
How do we do staging and
Content variables, huh?
so how do we deploy staging in multiple locations, or how do we?
Geolocations.
Right.
Yeah.
That's more of an infrastructure. This still works. The same process. We just have the AMIs in each location,
Okay,
and
so
when the
it's
deploy happens,
okay,
yeah,
like
they
a
just
master process and go through the workflow that way. So you have one location. Pretty much we have the master process. Just replicate the physical centers.
yeah. So the question was, do we have a master process versus, and then that replicates out to the geolocation areas. It's more the apps run in each location according to their config files. Then when you do the deploys, once you start going multiple region, one of the things you have to be really careful of is making sure that the apps can interoperate with each other with N+1, like whatever version they're at, they have to be able to work with the version prior and the version ahead in the software, because you'll never be able to get the deploy done in every location at the same time in a short enough window that you don't get a conflict.
So staging is important.
Staging is very important in that case. Yeah. So the way that gets solved is that it's just a different region. You do the same deploy, but you would roll out your deploy. So you do West US first, it's good. East US, good. Europe, good. And you just do it like that. Just takes longer to deploy, but yeah. You got a question at the back?
It's not a question, it's an observation that fully baked AMI approach that you use is one that Netflix uses.
Yeah, exactly.
It optimizes, if you're optimizing return to service and or fast scaling, that's the way to go.
Exactly. That fully baked thing has saved our bacon many, many times. I mean, another example where that's really helped is we had a client app that was running and one of their processes just started chewing memory. And it was only one of the 5 app servers that were running and it just went ballistic, right? And it was timing out and everything. We just took that out of the group and let the system boot another one. And then at our leisure, logged into the one that was memory leaking and doing GDB and stuff on it to figure out what was wrong. So this process really helps. Unfortunately, to do it manually takes quite a few steps, but even on hobby apps, I mean, I've got a hobby app that's not on OpsCare, and I do it manually. I just create a new instance of this, don't reboot it, that's the new image, good, done. It's not super hard. So the next part is that processes should be considered first-class citizens effectively. So each part of your application needs to be its own sort of process. Now, Heroku do this, they have web, worker, and DB, and like all these sorts of different instances. We do it as well. We actually constrain a process to an entire instance. So you'll see, and I'll do a live demo in a sec and show you what I mean. But like the workers have their own instance and the web has its own instance. And then we just boot up multiple of those. So you treat the process as the first-class citizen. And then you also never have a situation where no individual process is irreplaceable, right? If you have one web worker or 20 web workers, it shouldn't make any difference to your app. And that's an important step. So I'll show you something on that. If I hit escape. Okay, good. This is going to be fun. So this is actually our main production Rails environment for our website. And what you can see here is that it's a very simple, I mean, it's just a simple website, right? It doesn't have a lot of background workers or anything, but this is running our website at the moment. So you'll see that we've got 2 auto-scaling production web workers there. And why that's useful is that if I logged out and went into another app, we might have workers here or other types of process, right? And you might have 1 worker or 5 workers or 10 workers or whatever you need. But each of these is a process and you can nuke them, update them, do whatever you want to them, and they'll just come back live. So having each, we call these roles, but process is the same thing. That's a web role. And then each of those are an instance. So if we wanted to pull that out of the group, we could, and a bit later I'll actually go ahead and just destroy one of those on the live production site and it all should keep working because, you know, demos always work. So the next one is port binding. Someone asked about that before, or something similar. They were asking about connectivity with microservices. This is where you want to run that. This step of port binding basically means that if I want to talk to an application, I need to know that that's just running on a certain port, you know, port 3000, port 8808. What it means is you don't want to daemonize stuff and be connecting via sockets and things like that. You want to be connecting via a port. The reason for this, one of the major ones is these 2, right? It allows apps to back other apps and allows you to migrate to macro microservice. I don't know if macroservice is a word, but I just coined it. If not, otherwise you heard it here first. I consider a macroservice where you've got a couple of really large apps that are just sort of interconnecting somehow. The other nice thing about these ports is it allows you to run your development environment right, just like your production environment, because you can boot up a server or a database. Yeah?
Is this binding to DNS?
No, binding, so like if you've got, say, localhost port 3000 and that's where you're connecting to your app, or 88008 or 443.
For URL versus DNS.
Yeah, it doesn't matter if it's DNS or not. You might be behind a firewall and everything's connecting via IP address. That doesn't matter. It's more about where you're connecting to. So instead of connecting via the file system like a socket, you're connecting via a port. The The reason for that is that if you're connecting via a socket, so say you have a traditional LAMP stack of Linux, Apache, MySQL, PHP, quite often they'll be connecting via a socket.
Yes.
And the problem with that is that you can't then just take the MySQL server and move it out
Yes.
because, well, it's not on the same machine. So, but if you're connecting via a URL, you just have to change the URL and you could have it on a different box. So that's what port binding is all about. Make sense? Any other questions on that?
Yeah. So in the variables, does that mean you have an alteration of ports to choose from and then select a
Yeah, I'll show you. Yeah, so for example, these are the environment variables. Okay, that's a bit useless. Oh, there you go. So like Redis on my local box is just connecting via a port on that. And these Braintree accounts, this is like the template one, so it doesn't really matter. These secrets don't matter because that's just local development. But yeah, see I've got the domain name set, these app IDs and stuff like that. So obviously in development, you'd fill out these. And I was actually first, when I was saying, can I show you this? I was looking at my development one and then I realized I could just show you this one. Didn't want to give you my Braintree merchant ID, I'm sorry. Because we've got photos being taken and this is being recorded. Yeah. So yeah, that's how it would work, right? But you see the advantage of this Redis URL? That's just pointing to a local one. On my development box, I could just as easily connect that to like Redis to go or something, you know, and just test to see if it works. So that's where port binding really comes in handy.
So anywhere you see somebody do something, for example, like you've got the pattern of fronting reverse proxy server like Nginx, where it's talking to a local Unix domain socket, and say, okay, you don't really need, let's go ahead and sacrifice a little bit of the performance, and even though it's local, let's go ahead and bind this.
That's right. So the statement wasn't really, so the statement's more like if you had traditional web request coming in to a front-end load balancer, which is doing a reverse proxy to a set of app servers. Instead of going via a socket, do it via a URL connection. Exactly, port binding. Because the main reason for that is that right now you might have your front-end reverse proxy and your app servers on the same box. You start scaling and you need to split that out. Well, now you've got a problem, right? You're going to have to re-engineer your infrastructure to put that URL in. So it's where port binding comes in handy. Yeah?
Even if you say you run Java applications in a Tomcat.
Yeah. So the statement was that having individual processes rules out PHP and Java. Yeah. It's not, I mean, what you can sort of get around that by going, my Apache server is a process. Like, it's not perfect, but it's sort of close enough. Like in the old days of Rails, it used to run via like a CGI bin. Rails grew out of that and started having mongrels, and then it became unicorns, and now we've got pumas and whatever else. And we're looking for the next magical creature for the next web server. Yeah, no, but the workaround to that is sort of treating your Apache instance as a process, right? So the way you would do that is you would run your Apache instance for that PHP and nothing else, right? And then if you wanted to run a static site, boot another Apache instance or put it on another box or do something like that. Any other questions on that? No? Okay, cool. Concurrency. This is one of the most awesome things about 12-factor. Processes are first-class citizens. They should never daemonize, so they should always be running. And in terms of daemonizing, it's more along the point of you don't want to have one box that has multiple different things running or separately. You want to be able to know that this box is running the blah, right? So sometimes, it's not like, when I said at the start, there's a range of 12-factor and it sort of goes from totally in to totally out, and you're somewhere in between. Like in OpsCare, we do put our unicorns in background workers, but they're the only thing running on that box, so it's sort of okay, right? It's just so we don't have to keep an SSH connection open to it. Shared nothing, horizontal architecture, adding concurrency is simple, reducing concurrency is simple. So then you get a picture like this, right? Where you have multiple web roles, multiple worker roles, and you can scale these individually. If you add 5 more workers, you don't have to touch the web. If you add 10 more web, you don't have to touch the workers. This becomes really handy when you're handling situations with scale, because quite often you don't need to scale the web instance, it's just that someone on your Wolfbook page has uploaded the last 10 years of their favorite dog photos and the workers have all died because there's not enough capacity, right? So this sort of thing also works really well with services like AWS spot instances, right? If you have a 12-factor system and your concurrency works such that it doesn't matter if actually it's one of the next 12-factor points, but if the instance dies, it puts its job back on the queue, that's a 12-factor point, right? And if you have that, you can then take advantage of spot instances and stuff for your worker roles because it doesn't matter if they shut down, right? So yeah. So for example, on the concurrency, we can do this with our ops care service. We're specifying a role here, which is our term for a process. And then we're just saying we want staging to be 2, not 1. And then it just goes through, boom, 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 starts another one, and ends up, and it's running. And similarly, we can then go also ops care scale set staging to 1, and it will just kill the other one, and we're good again, right? So this is where that sort of scaling with immutable AMIs and being able to change your concurrency very simply, it's very useful. Which leads on to disposability. So every process should be able to be killed at any point and it not affect your app. And someone brought up Netflix before. They have this great thing called Symbian Army, which just randomly goes through their system and kills servers, right? I mean, mind blown. But if you've got 12-factor, it's like, yeah, okay, whatever, you know? Because, yeah, I'll show you. Let's do a live demo. If we go into production environment, and we take this one, and we can just terminate it. Yes, I know. It's terminating. So that's our main production app. Yeah, we're still running, so that's good. Glad that demo worked. So we're just nuking one of our instances there. And because, obviously, if I nuke the second one, that's going to be a problem. But because it's on 12-factor, we can nuke that instance, and in about 2 or 3 minutes, it'll just replace it.
Behind an ELB.
Yeah, this is behind an ELB. Yeah. That's what disposability is all about. You should be able to do this to your environment. And when I'm doing ops care demos to new clients, I always do this, and they're always like, you sure you... Anyway, it's always good. It's never failed me yet. Thank you, computer. So this whole idea of disposability, yeah.
Are you using an AWS autoscaling group, or do you have something else?
No, that one's just AWS autoscaling. And then what happens is in the deploy, we change the launch configuration to point to the new AMI at boot. And then when we do that deployment, we copy the launch configuration to a new one, change the AMI number, and we're all good. So this is what you just saw is possible because we're on 12-factor, right? This build, release, run process means that it minimizes boot up time. And if we go across that, I don't know if it's been long enough yet. Not running, let's change that. Yeah, so we're already starting up, it's already starting up a new instance, right? So this new instance is now initializing. That's a new copy. You can see the old one that's died. That's now going to pull down the environment variables. It doesn't have to do anything as it's booting. Like it doesn't have to run a chef script to configure the box. It doesn't have to contact some service to find out what version it is. It doesn't have to pull the latest version of code down from GitHub. It doesn't have to do any of that. All it has to do is initialize and boot, and it's probably close to done by now. There you go, it's in service, right? So from killing an instance, it recovered in what, 3 minutes? It's doing that because it's fully baked, that's right. So if that wasn't fully baked, now that it was running, it would now be booting up a chef worker or doing something or pulling down the latest code from GitHub. And the problem with that is you don't know what the latest code is. You know, this might have gone down just as someone's pushing a new commit to master ready to deploy. This goes down and now we've got 2 different versions of code running and no one knew because this blew up of its own accord. And then the developer goes to push production and looks at the site and production's already there and they're like, what's going on, you know? And then that code is actually broken and they only find out after it's gone into production. So now you're running 2 different versions of code. Anyway, nightmare. So that fully baked thing really is really cool. Processes should shut down gracefully when receive SIG term or you terminate them from the console. They should respond to sudden death and that should be cool. They should be happy. I actually really like Netflix's thing. They released something else where They randomly send a staff member on leave for the day, and the whole organization has to be able to cope, which I think is pretty funny as well. So not only do they randomly kill servers, they randomly virtually kill employees. So there you go. The other thing about this is removing concurrency is really simple. So that same scaling command, I can just type scale to 1 and it's just going to reduce. And it just kills one of the boxes. And it doesn't matter, it can pick whatever box it wants. So live demo, we just did that. 2 more left. Environment parity. So 3 more, including this, if you are paying attention. You want to use the same services in all environments. So one tempting thing is to go, well, I'm using Postgres on the server. I'm going to use SQLite in development. Don't do that. Just run a Postgres box. You really want to hit the bug on your local machine before it gets into production. That really random index problem, which only happens on production servers, yeah, just run the same stuff locally. You'll be a happier person.
Well, for situations like unit tests with some type of fixture with like SQLite or things like that.
So the question was about unit tests with SQLite. Just go with Postgres.
So the same thing all across the board.
Yeah, if you can. I mean, like, there might be situations where you can't do that, but they're going to be pretty rare. And the time that you save in running it locally, you could probably figure that out other ways. Like, you might, some people have run SQLite and machine, like memory, to make it faster. You can actually tell Postgres to run that database in RAM, and you can achieve close to the same performance. Just one sec. Yeah? Yeah. Yeah. Don't use RDS. No. Yeah. So if you're running Postgres 9.3, run that 9.3 locally if you can. Yeah.
So if you're talking to a database, for instance, you're not doing unit tests, you're testing the database. So you do a dependency injection with mocks and stubs. Mocks the object, stubs the behavior.
Right. Yeah. So the other point is that when you're doing testing locally, you not actually need to test the database. Like, the Postgres team have probably tested that the database is ACID compliant. So you can mock all of that out anyway and not hit it. Yeah, totally, when you're running your tests. But when you're doing your actual, pre-go live testing or something, then you want to hit the actual system and, yeah, keep it the same if you can. Nice thing about 12-factor apps is they are designed really well for continuous integration because everything is in the app and it deploys itself and it knows what it's got. It's very easy to put that onto a CI server because it just starts, because it knows what it needs to do. So it's really handy. Environment parity. Heroku have a thing called Foreman, which really helps with this if you're using Heroku. That helps you boot it. Docker can do this, can help you with that. But also, just a really good README also helps. For Rails apps, for example, all of our OpsCare apps have a README, and our litmus test on is the README good enough is if we give this to a brand new developer, can they start coding in under 10 minutes? Not including install time of whatever they have to install, but can they just do rate DB setup, bundle install, done, and maybe brew install blah or brew install blah. As long as that README helps them get to that, then you don't really need something like Docker. Docker is cool. There's nothing wrong with Docker. We don't really need it in the OpsCare environment the way we do it. We might include it later. But yeah, it's up to you. Don't feel like, well, I guess what I'm saying, I'm not being anti-Docker. I'm just saying, don't feel like you need to migrate to something like Docker to achieve this. You can just do it with a good README. There was a question.
Just a comment as a former DevOps guy that has used engineers README. Actually test them and make sure they work.
Yeah, that's right. So the comment was, test your README and make sure it works. Yeah. So we do that. That's one of the things we do on our code care service. Is the code care engineers run through the README every couple of months and make sure it's up to date and it still works. Yeah.
So we use Docker. We use Docker, but I've heard things about vagrants.
Yep.
And, trying to keep parity with production on the local machine.
Yep. So he was mentioning you could use Vagrant as well. Exactly. I mean, how you achieve this, again, is an implementation detail, and it's what's best for your team. All I'm saying is don't feel like you need to over-engineer it, because really you don't. In our case, we're an extreme case. Our developers sometimes have to keep 10 or 20 different Rails apps working on their box, right? And even with that, we don't have to use Docker, right? So we can do it with READMEs and isolation of gem files and stuff like that, and it works. In extreme cases where we're really running really old versions of Ruby or something, we might end up booting a Vagrant box on that or a Docker image or whatever, but it's up to the developers. Okay, good. Second to last, logs. So your application should not give a damn about how the logs work. It should just dump it all out, stand it out, and go, my job's done here. You don't want your app trying to figure out, do I need to buffer this output, or do I need to do this? Just dump it, right? Your 12-factor app should capture that. The environment should capture that log and do something with it. You might put it in Splunk. We have a certain system that we have that gathers all the logs and compiles them. Heroku does the same thing. So don't worry about the logs, just dump them to standard out and your infrastructure should handle it. Admin processes should run as if they are just like any other app or process. So you don't want to have to, like ideally, you'd spin up an instance to run your admin process and then kill it. Yeah, we don't necessarily do that on Omscape, but on Heroku they do. Like when you boot up a console, it actually boots up a console for you that is dedicated for that, running in that environment, which is cool because then it's scaling and you're not impacting on your web servers and stuff like that. So part of what makes this work is that 12-factor strongly supports languages that have a REPL. So this doesn't work very well with Java or a C instance. That's right. That's true. Yeah, you can do it that way, a closure in Scala. So yeah, it does prefer those sorts of things, but anyway, admin processes need to run as a first-class thing. So how could new guys and girls all 12-factor? Well, build it or buy it. I know what to say. The simplest way to do it, just put it up on Heroku, follow these steps, you'll have a 12-factor app. If you're running Rails, you can talk to myself or Jarrett over there. Hi, Jarrett. Wave for everyone. He's got... we can help you get your Rails app up. CloudFormation can definitely help you if you follow CloudFormation and use it properly. And you'll need to use something for the configuration management. Chef, Ansible, Puppet, insert your tool of choice here. The reason for this last one is that you don't want your infrastructure build to be a manual process, right? That sort of violates the 12-factor principle. Because if you make it a manual process, in 3 years' time, when you go to do it, you're going to have to remember those manual steps. You want it in code so that it runs the same way every time. So, should we 12-factor? Well, only if you want to sleep at night. So, yes, I guess would be the answer to that. So, that's it. Thank you. And if there are any questions, feel free to ask me.